near net safe forming based on powder metallurgy, green machining and lamination. And also for bottom up approaches, we use the electrospinning, 3D printing, casting, laser patterning, spinning and freeze drying, etc. So, we have developed few of the technologies. I think I can give you a couple of examples. So, protein coagulation casting is one of such technology. PCC, we used to call PCC back in 2004, and using this technology we got IIM Ahmedabad award. So, with the award money I think we formed the company which was and ceramics, and today as you know and ceramics is doing very great job, and you can see every corner of the country and ceramics are there. In my PhD days we have developed the products, we sold in the market, and also we have given to professors, those who are using some of the products for the applications they otherwise purchase from abroad, but we just made the product and we have given to professors at IIT Kharagpur. Similarly, the coagulation assisted foaming is one of the technique which was developed in my tenure of IIT Kharagpur as a faculty, and students are now faculties. One of them is at IIT Ropar and one of them is in Naipar, Kolkata. So, I think they have developed a titanium dense and porous materials using a very simple process. Otherwise, if you look at titanium manufacturing processes, very high tech process, because titanium is very prone to oxidation and very sensitive to oxygen. So, we have developed a plastic dough processing. In fact, many of the machines in the lab, if you see that, we actually work in the drawing room with the students, we interact and we sketch, then we finally talk to a vendor in Kolkata or Howrah, and then finally we visit the site and talk to them, and we make some machines, and sometimes machines are lying maybe 1 year, 2 year, and finally we start working on that and we get really good results. So, that way I think it is a game changer for the group, as well as even with a very low investment in the lab, we do have a lot of outcomes. So, near net safe forming and green machining I think I am doing for last 25 years, and here a lot of optimization, standardization, as well as the shrinkage studies are very important to make near net safe to exact size and shape. So, what you can see here, these are some of the scaffolds which are made by plastic dough processing or BPP. These we made the ceramic tape and machined, then we laminated, then sintered into scaffolds. Similarly, we have taken a CT images, and then from CT image we have extracted the mandible, and using this extracted mandible, so we have made the customized mandible made of polymer and ceramic fiber composites, and this mandible is flexible. I remember Professor Martin Brown was visiting from Southampton University. He was quite interested to collaborate for this kind of research, and we do have collaboration. Professor Sanjay Gupta and Professor Martin Brown together, we have certain collaboration, and we also developed a ceramics which are machinable, and we developed the tool which can be used for machining. Can you please? Yeah. No, previous, yeah. So, what you can see here, the tool which was developed by interacting with a company in Kolkata. So, otherwise there are carbide and diamond coated tools which are available from Sandvik Asia and maybe Vidya, and these tools usually I have used in UK, which are highly expensive. One tool will be costing like 5,000 rupees, and here I have developed a tool which is just a very simple tool, and the costing is about say 100 rupees, and based on this we have actually filed a patent. I think DVT asked us to file a patent, and based on that we are able to make customized dental crowns and dental roots using the tool as well as machinable ceramics. Can we change the slide maybe? Yeah. So, you can see here Dr. Sandeep Sisala. I think the previous work was done by Dr. Sarala Sita Mohanty. This work is done by Dr. Sandeep Sisala, where we have made the zirconia and alumina crowns, root and breeches. Again, it is a customized dental crown and roots, and we have again taken the green machining approach as one of the major approach, and you can see that we are able to make very fine threads using our process, and also we are able to coat alumina on the surface to overcome the aging effect, and I think this work was praised by the renowned scientist from France, Professor Chevalier was actually phrasing a lot on this. Can you go to the next slide, please? Yeah, I think if you go, yeah. So these slides is close to my heart because I am teaching this for last 15 years. So as you can see here, so this is the mason's work. I hope the top one is not desirable and bottom one is most appropriate one. So as you see here, the wall has to, newly built wall has to cross talk with the old wall, otherwise you can see there is a failure. So as you see, the implant failure analysis for last 20-30 years, failure always happens at the interface where the materials and bone are working together. So it is, this failure is mainly because of stress shielding effect, as well as there is a mismatch between the bone and the materials. There is a very poor bonding between materials and the bone. And therefore, here Halbert has proposed a concept in 1960s that if you make a macroporous material but bioinert material, so there will be foreign body responses and fibrosis. Because of the fibrosis, there is a fibrous tissue which will